Problem number 61. A circular hole in an aluminum plate is 3.115 centimeter in diameter at 0 degree Celsius. What is its diameter when the temperature of the plate is raised to 180 degree Celsius? So let's we see these two diagrams. So this is the initial case, this is the final case. So initially you have this aluminum plate which has a circular hole inside. So by that the diameter of the hole, here they mention di, which takes the value of 3.115 centimeter at a temperature 0 degree Celsius. And now what you are going to do, you are going to find the final diameter df after you heat the same plate at 180 degrees Celsius. That means your T final value here is 180 degrees Celsius. So what we studied in chapter number 18 about thermal expansion. So here the diameter expansions, it's exactly similar to a linear expansion concept. So initially your diameter di takes the value of 3.115. When you subject this plate to some different temperature, what will happen? Its diameter will expand linearly. By using this, we are going to find what is its diameter. That means df value we are going to find. That means the d final. So for that, let's we take the formula of linear expansion. What's the formula? The formula for linear expansion is given by the rule delta L, which is equal to alpha L naught delta T. This is the rule we studied. And now what I'm going to do, because here we are going to find the diameter will be expand linearly. So we can use the same thing in terms of, so I'm going to replace this L in terms of D. So how we can write this? We can write this as delta D. So let's delta small d. Here small d is not a distance, it's a diameter. So delta D, which is equal to alpha D initial multiplied by delta T. So here your delta D is nothing but D final minus D initial. So that means final diameter minus initial diameter, which is equal to alpha. That means the linear expansion coefficient of aluminum is a constant which takes the value. So the alpha value of the aluminum, which is 23 multiplied 10 power minus 6 per Celsius degree. For every change in temperature, the value of the expansion for aluminum is 23 multiplied 10 power minus 6 per Celsius degree. And here di multiplied by delta T. What is delta T? Tf minus Ti. Now by using this, we are going to find the value of df. So because that is our main aim, to find the answer for df, so we have to rearrange this equation. So what I'm going to do, I'm going to keep this df here, I'm going to move this to the right hand side. So by that, this equation becomes di plus alpha al di multiply tf minus ti. So here we can take di as the common term. So df, which is equal to di, I'm going to take as a common term. So 1 plus alpha al multiplied by T final minus T initial. So now I'm going to substitute the value. So the value of di is given as 3.115 centimeter. So I'm going to leave everything in terms of centimeter. So d final, which is equal to 3.115 multiply 1 plus the alpha, that means the linear expansion of the aluminum. The coefficient of the aluminum is 23. It's a constant, so it will be given in your exam, so don't worry. 223 multiply 10 power minus 6, and then your final temperature is 180 degree minus 0. So we'll get this. So let's see what's the answer. 3.115 multiply 1 plus 23 multiply 10 power minus 6 multiply 180. So I got the answer for D final, which is equal to 3.128 centimeter. So this is the answer for this question. That's it. Thank you.